All right, guys, when we stopped the first recording of this lesson, we were on part A, and I was writing with the mouse, and it was really, really hard to follow. So now we're going to finish this packet, and I'm going to try to type as much as I can. So when you get to part B, it says, how much would this investment be worth in 20 years? So we take our equation, and for the time, we now have 20 years. So the amount in 20 years, $350. E raised up to the 2% over 20 years. When you do that, you should have gotten, if you type that in along with me, $522.14. Then you get to part C. Algebraically determine the time it will take for the investment to reach $400. Now, if you recall, when we were doing this with just exponents, you would have had to have in Y1 this original equation. In Y2, you would have had to have 400. You would have had to copy the table. You would have had to reset the window. You would have had to graph both, and then you would have had to find the intersection. A ton of work. If we now take the $400 and we put it for the amount that we want, and we use logs, we'll solve this quite quickly. So again, just like before, when you're solving an equation, it is the reverse of the order of operations. The variable's in the exponent, and the exponent is more important than multiplication. So we're going to divide this 350 out on both sides. So when we divide both sides by 350, this is going to go away, and this is going to go away, and then we are going to be left with this. Oops. I have to erase that. There we go. So we are now left with 1.1429 equals e to the 0.02 to the time. Now, the only way to get an exponent out is with the log, and since we have e, we have to use the natural log. So when we use the natural log, let's see, yeah, there it goes. We have both sides. Now on this side over here, we have to remember that the natural log of e, these guys are going to cancel. And now I have the natural log of this over here that when I type in, let's see, gives me 1.1336 and equals now my 2% times the time, because the natural log and Euler's number cancel, and down drops my exponent. So again, if I am going to do this correctly, I now have to divide both sides by the 2/10. And so when I do that, I end up getting that my time is 6.7 years. That's not a minus sign, that should have been an equal sign. There we go, 6.7 years. Now, it will take 6.7 years for this account to reach $400. Part D is saying, what is the effective annual interest rate? Well, this is going back to those mindful percents. I know how long I was doing this for now, and I know that I made the $400, but now I want to know, well, really, did I just make 2% per year, or did I make more than 2% per year? So that actually brings us to looking back. And here, this was the problem that we had. Now, the thing is, if I want to go back and find out effectively what did I get each year, I need to go here, and we're not going to use Euler's number anymore. We're going to say, what was the overall growth rate? What was the base? And the base came from up here where this, let's see, this wasn't the 0.02 over the time. Now we know that this time was 6.7 years. So now here, let's put in our 6.7 years. So here I now have this equation, and I'm like, okay, I got to get this 6.7 years away so I can find out what the overall growth rate was over this time. So we're going to use exponents, and the only way that I can get rid of an exponent is with its reciprocal. So I'm going to have to use the mouse for this. I need 1 over 6.7. And then this would cancel my exponent out. See, then down would drop my base. And if I do that over here on this side, I better do it, whoa, let me try that again. I better do it over here on this side. So here I have to make a parenthesis around this side and have my 1 over 6.7 years. So when you type in your 1.1429 raised up to the 1 divided by 6.7 years, you end up getting on your calculator 1.0202. Now, remember, if this was now becoming the base or the growth rate, we still have to say, and we had the 100% of what we had begun with, which is always our 100% in decimal form. So back to the original page, this would have been the 1 plus. This adds up to a 2.02%, 2.0202 actually, but I'm just going to write 2.02%. So compounding continuously gave us more than a 2% growth rate. And this was only for 6 years. So if it was longer, you would make a whole lot more money. Now for homework the Thursday, March 12th that we were in class, you were supposed to have done 1 to 5. So here's the answers to that homework. Number 1 was 1, number 2 was 2, number 3 was 4, number 4 was 3, and number 5 was 4. So that was your homework. Now let's do another word problem, and after this word problem, I'm going to give you a new page with word problems, which will be your assignment for April 1st, when, now that we're back to school. So let's take a look at this guy here. All right, so an investment of $500 is made at 2.8% interest compounded quarterly. Now, when you're compounding quarterly, this isn't just your 2.8%. Remember, you have to divide this by 4 because you're doing this 4 times a year, and then that makes your exponent 4 times the time. So this is your compounding formula. So then if you divide 0.028 by 4, you actually get 0.007. So this growth rate now would be 1.007. So now if I want to know what this investment is worth in 10 years, the amount in 10 years is the $500 initial amount or the principal, the growth rate 1.007 because, again, quarterly, and I do this 4 times a year for 10 years. And it turns out in 10 years, I have $660.92. Now, part C, what would this investment, how long would it take for this investment to be $800? Well, that's just like the problem we had just done. Here's the $800, and here's my initial investment and my growth rate and 4 times the time. I have to divide both sides by 500. When I divide 800 by 500, I get 1.6. And this is now equal to my 1.007 raised up to the 4 times the time. Now, just like before, I want to get rid of this exponent. I'm going to use a log. Now, I'm going to use a natural log just because the natural log is the one used most often when it comes to percent problems. So if I have natural log of 1.6, and then I put the natural log on my 1.007, which would be raised up to the 4t, what's now going to happen is my natural log and my 4t, the power rule is going to happen. So when I type in, this will be natural log of 1.6 is now equal to the natural, 4 times the natural log of 1.007. So when I put the natural log on both sides, power rule brought the exponent down in front. Once that happens, then I can divide both sides by the natural log of 1.007. And at this point, you're going to have to type that guy in on your calculator because I don't really see anybody getting this without that. So when I type this in, I'm going to move my work up to here. I get 67.3781 is now equal to 4 times the time. Now I have to divide both sides by 4. And that's going to cancel my 4s over here on the right. And 67.3781 divided by the 4 gives me that my time is now 16.84 years. And they wanted it to the nearest hundredth, so you had to have 2 decimal places. So part D, why does it make more sense to round your answer in C to the nearest quarter? State the final rounded answer to the nearest quarter. It makes the most sense because you're rounding quarterly, so if you were going to talk about each quarter, you would say in 16 3/4 years. So instead of 16.84, we're going to round it to the nearest quarter of the year, and that would be 16.75 or 16 3/4 years. So we'll write that down. So this would now be 16 3/4 years, rounding it to the nearest quarter of the year. So after this, now I'm going to put up another worksheet of word problems. This is your work that is due on April 1st. So hopefully April 1st you'll go on, you'll watch these 2 videos, you'll work through the work that we did in class on the Thursday before, and you will then continue on to finishing the packet and doing this new word problem. And if there's any questions or concerns, please email me so that I can help you out. Thank you.